Hey guys, welcome to Section 1, Chapter 2 of the Geometry program. And over the next couple of sections, we're going to work with logic. And logic is the basis of mathematics. It's kind of different than what you guys have been working with. I think that you'll probably like it. So I apologize in advance for all of the definitions, but let's go through them. A conditional statement is any statement with an if-then format. So an example would be, if the weather is warm today, then I will go to a pool. So it's in the if-then format, it makes a conditional. What that means is the end of the conditional, called the conclusion, is contingent upon the first part of the conditional, which is the hypothesis. So the hypothesis is the if part, the if phrase of the conditional, and the conclusion is the then part of the conditional. This type of statement is really important to us because we're going to be able to determine whether a particular conditional statement is true or not true, and how we do that is by looking at things like a counterexample. You might have heard that term before, but a counterexample is an example that proves the statement false. So it's a situation where the hypothesis is true, but the conclusion is false. This is the application to conditionals for our purposes in geometry. So today we're going to learn how to write conditionals, identify the hypothesis and conclusion. We're going to evaluate the truth values by finding counterexamples or being able to determine that it's true. And then also do something like this, and this is our setup for our next section, but we're going to talk about something called the converse. And the converse is when we switch the hypothesis and the conclusion of a conditional statement. So without further ado, let's jump in. If you need to pause the video to finish your notes, please do that. Okay, so the statement is the number 1 is the smallest positive square. If we're going to write this as a conditional, we need the if-then format. So if the number is 1, then it is the smallest positive square. When we write the conditionals, we're going to have to change the wording just a little bit, and that's okay. You're going to see that more even with the next one. So don't worry about that as long as the essence of the statement is there. If you have to change a few words, that's fine. And then let's identify the hypothesis. So the hypothesis is the if statement. The conclusion is the then statement. Okay? We're going to come back to that example to evaluate truth value and the converse, but first I want to practice writing the conditionals and identifying the hypothesis and the conclusions. Okay, the next one, all four-sided figures are squares. So if we're going to write the conditional, we would say if a figure is four-sided, then it is a square. The hypothesis is the if portion. The conclusion is the then portion. So if a figure is four-sided, then it is a square. All right, let's do one more. All right. In order to write the conditional, a square with area 100 meters squared has sides that measure 10 meters. So if a square has area 100 meters squared, then it has sides that measure 10 meters. If a square has an area of 100 meters squared, then it has sides that measure 10 meters. The hypothesis, the if portion, the conclusion, the then portion. Okay, so now we're going to go back up to our first example, and we're going to evaluate the truth value of this. And if we determine that it's not true, we're going to provide a counterexample in order to be able to say that it's false. All right, so if the number is 1, then it is the smallest positive square. Remember that squares, like if we did 1 squared, that would be 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. All right, so if we evaluate that, 1 is the smallest positive number, right? That is a whole number, which could be a square. So this has to be true. We cannot come up with a counterexample. We examine the information in the conditional, and we determine that this conditional is true. All right, what about this next one though? If a figure is 4-sided, then it is a square. Well, hopefully pretty quickly you can say, actually that's not true. So a counterexample would be a rectangle. That is a 4-sided figure. That is not a square. You could also do a rhombus. You could also do a trapezoid, right? But we only needed 1. And in providing just 1 counterexample, our conditional is false. Okay? Let's do one more. If the square has an area of 100 meters squared, then it has sides that measure 10 meters. All right, think about this. We have a square. We know that the area is 100 meters squared. Both sides have to be the same. Is there any other number besides 10 such that when you multiply it times itself, you get 100? And the answer is no, meaning we cannot provide a counterexample telling us that the conditional statement is true. Okay, I want you to practice this one by yourself. I'm going to have you pause the video. I want you to write this as a conditional, identify the hypothesis and the conclusion, and then provide a counterexample if it's false. Otherwise, tell me that it's true. So pause the video. Okay, you guys, let's go ahead and write this. If you see lightning, then you will hear thunder. If you see lightning is the hypothesis, then you will hear thunder is the conclusion. And the question is this true? I can think of a counterexample. Maybe you could, maybe you couldn't. There's something called heat lightning. And in that case, you would not hear thunder. You just see the flashes between the clouds. And in that case, that would make this statement false. Okay? All right, there's one other thing that we want to talk about, and that is writing the converse statement. So the converse statement is going to switch the conclusion and the hypothesis. All right, so in this case, I'll just draw myself a little box here. You'll have more room on your notes, I'm sure. Okay, so to write the converse of this conditional, we would take the conclusion and make it the if statement. If a number is the smallest positive square, then the number is 1. All right, hopefully that's not too complicated. You're going to take the conclusion and make it the hypothesis. And again, you're going to have to switch the wording a little bit, so don't be afraid to do that. This is an English class. This is about assessing truth value to logic statements. So if a number is the smallest possible square, then that number is 1, would be the converse. In the next section, we're going to try to identify whether both the conditional statement and the converse are true. But in this section, we're just going to be writing it. All right, so for the next one, if a figure is 4-sided, then it is a square. If we want to write the converse, we would write, if a figure is a square, then it is a four-sided figure. So if a figure is a square, then it is a four-sided figure. And that part is actually true. All right, let's do one more, and then I'll have you practice the last one. All right, if a square has area 100 meters squared, then it has sides that measure 100, or has sides that measure 10 meters. So if the side of a square is 10 meters, then the area is 100 meters squared. So the conditional, if a square has area 100 meters squared, then its sides have measured 10 meters. And then the converse is if the side of the square is 10 meters, then the area is 100 meters squared. All right, I'm going to have you try this last one. So pause the video, write the converse of this conditional. All right, you guys, hopefully you got this. If you hear thunder, then you will see lightning. All right, that's it for your first section. So finish up your notes, read through the examples in the book, and begin your assignment.